So our project is on preventing shoplifting with the use of advanced security by Rajdeep.
Rajdeep. And armor for that gun.
So what is the problem?
In the United States, there's been a huge disaster in shoplifting. Lots of money is being lost. Due to negligence by the police, and due to the fact that shoplifting is so easy to get away with. It's been happening in stores everywhere in the U.S., from big box stores to even dollar stores. As you can see in this chart, shoplifting has been regularly rising since 2010, but then it shot up during the COVID decade. It shot up during 2018 and then declined until the pandemic, where it has been rising ever since. Shoplifting is estimated to cause at least $13 billion a year in losses for the retail industry, and 57% of adults and 33% of juveniles say they shoplifted at least once. The research and justification. Look, there's been a lot of things that have been happening that causes this to become a really big issue. The prices increase for whenever due to all the loss of estimated 1.4% shrinkage each year, and a 37% loss to the external threat. And the tighter security is also very expensive. So this is causing increased prices for us as consumers. The existing solutions are often ineffective, expensive, and unreliable. We need time to train employees to use them, and they often have to be manual instead of being used with the AI. You see here the professionals. We have some experts on the industry, specifically people from the police department. They've not given us we thank them greatly for their great insight that they've given us. A quote by one of them says, "Shoplifting is not taken that seriously by law enforcement. In certain states like California, you do not report shoplift to law unless the goods are worth at least $800. And that many stores let the shoplifter get away with it due to how hard it is to prevent shoplifting and the possibility of a lawsuit. If somebody gets injured. This has made shoplifting extremely hard to solve.
So here's our market survey. So we have various graphs where we basically start to individuals in the public, in retail stores as well. So the surveys basically consist of Google Forms where they basically respond with, do they consider shoplifting to be a major problem? What are the various different categories of shoplifters? Which one of those categories do you think would best define a shoplifter? So we basically stated that over 60% of people believe shoplifting to be a major problem, as well as the three most common types being addict, thrill seeker, and compulsive. So now we have another slide. It's basically about the bar graphs indicating the comfortability with facial recognition in retail stores, and individuals they rate out of a scale of 1 to 10, 1 mainly, which is reasonable. It doesn't affect privacy a lot, so having facial recognition implemented in that way in a broader sense, it wouldn't really tickle people. And another bar graph indicating comfortability of people with current retail sources, the confidence level, basically. So it's rated 7 out of 1 to 10, but we can see that there can still be improvement in current retail store systems. So here's our existing solutions, current patents that have been developed to try and combat with shoplifting. Here's a camera system, basically trying to record people's movements and based on behavior, detect shoplifting through that. And here we have another patent. It's sort of an anti-theft gate system, portal system, where when some person walks through it, there's a camera inside the portal that's basically taking a close-up capture of the good with the use of the RFID tag and RFID reader built into the portal itself. So our present solution. So we try to incorporate, based upon those existing solutions, a parameter system of sorts. So where we can do multiple checks to check for various different categories of shoplifters, such as professional, compulsive, active compulsive, as well as thrill seeker personality types. And based on specifying those parameters, we can target various different shoplifters and detect them beforehand. So here's our basic criteria. So design criteria includes a high quality camera, basically for the facial recognition to be used efficiently. We need a close-up capture of the individual's image with the use of Raspberry Pi high quality camera. And we would also need to implement small computers such as Raspberry Pis and as well as Arduinos for a position tag idea that we tried to implement into the final product but did not end up making the product. Here is a process and layout of our project. So basically, for number one, we have the parameter system. The Raspberry Pi, which we use, is connected to the monitor and displays like the video feed of the Raspberry Pi high quality camera. So it basically takes high quality, not the Raspberry Pi high quality camera, I'm sorry, the WISE camera. So the WISE camera is an IP camera that we tried using to build the parameter system into. So we also tried to create a sort of check-in for the parameters as well, where if it detects certain types of motions that correlate to the shoplifter, it will basically check individually those parameters. Second process is the facial recognition system. So we have a Raspberry Pi high quality camera that's connected to the interior of the store, and the exit, or I should say, when a person's walking out of the store, it will basically capture the image of the individual after the parameters are checked for like a high percentage that the individual is most likely a shoplifter. So we'll take that image, store it into that database, and once that individual returns back to the store, the facial recognition will be booted up, and when they're exiting out of the store again, it will basically just match up to that existing image and basically send out an alert. We also have the third step, which is basically the position tags. So the position tags basically were attached to the goods within the retail store. So when the individual took the good out of the store and crossed a certain radius away from the store, or exited out of the store itself, it basically will trigger the LEDs and the speaker to turn on. And if they do not return the good by that time that they turned on, it basically sends an alert indicating that this is guaranteed, this person's guaranteed to be a shoplifter. Yeah, we also have various materials. We have the two Raspberry Pis actually. We have one Raspberry Pi 4B for the high quality camera for better performance, and we have a 2B for the WISE camera. We have peripherals, keyboard, mouse. We also have installed various libraries and packages, OpenCV, as well as NumPy. And we also have a total cost estimating up to $300 for our product. And then behind the scenes, for all for the facial recognition and for the parameters as well. Yeah.
Right, so this is the timeline for that engineering project. So the first thing we did was we first gathered all the necessary materials for the project, right? So we gathered the WISE camera, the Raspberry Pis, and all the high quality cameras involved with it. The next part was we had to connect the Raspberry Pis onto a monitor and install all the dependencies that were required for the program. So what we needed was OpenCV, NumPy, and all these sorts of libraries that will allow us to detect the shoplifter. And this was required for like the facial recognition program. And after that, we had to create a parameter analysis system, which basically checks for like the various parameters involved. So like speed, like motion detection, like the proximity of the shoplifter to the actual good. So these various parameters allow us to catch a particular shoplifter because they indicate how likely the shoplifter is to shoplift given the particular parameter. And after that, we configured all the components as a joint system. So what we basically did was we basically like connected the WISE camera to the facial recognition. So what this allows us to do is it allows us to get a better insight into the shoplifter overall. After that, we had to create like a visualization for like the particular parameter systems. So what we did do in our project is we basically calculated a percentage. So this percentage was based on the different parameters, and this percentage indicates how likely a person is actually to shoplift. Okay, so this is the proof of construction for our prototype here. So as you can see over there, so right here is the code for like the facial recognition, and basically this code allows us to basically see the shoplifter. So this is the actual image itself, and this is the image of me. So right here it says shoplifter because I stored my image onto the database, and this is like the real-time percentage at which the computer actually calculates how likely I am to be a shoplifter. And this blue box here is actually my image itself, it being detected. So the methods of testing. So what we first did was, in order to gain like my image, is I had to take a picture of myself. So what I did was I wrote a program that would basically like take a picture of myself and upload it onto a database. And so this is the picture of myself right here. And the database also allows us to only recognize my face. So like let's say if I'm wearing a mask, right? Like certain key features of my face, for example, eyes would also be detected. And this would basically allow an individual who's shoplifting to be able to be determined based on like the clothing they wear. And this right here is the Linux terminal. So a lot of, I would say like a good amount of the time we spent using the project, we were basically just using the terminal and we were like debugging the project because we did end up having a lot of errors. So we really needed to use the terminal to like test everything and like ensure like all the local dependencies were installed, like all the files and stuff like that. Okay, so this is the code specification and data collection. So what we used was a MongoDB database, and this database is a real-time database which collects information about shoplifters. So like specific information about shoplifters include information like speed, proximity, sound detection, and those are like the various parameters within the MongoDB database. We also have the WISE camera, which is essential for like collecting head movement, speech detection, and also speech recognition as well. So that can be helpful in terms of catching a shoplifter. And this was the code here that we had for like calculating the percentage of the shoplifter. So this here was for like the parameter head movement. And as you can see, we had to calculate the area at which like a particular shoplifter would actually like the greater chance by which like a shoplifter would actually shoplift. And we also had to use like various features such as blur and contour to like identify like specific features of the face. like for example, the eyes, for example, since it would have been, since it's one of the most important features in terms of actually like catching a shoplifter. Because eye movements are pretty essential in terms of how a person, how we can differentiate a normal shopper than a shoplifter. So project recommendations. So basically like some of the stuff that we would have tried to correct beforehand. So we first of all like broken our project into like smaller chunks, and we would have probably like tried to like instead of like completely like going over and trying to like go the entire thing by ourselves like in like a few weeks, what we would have done is we would have actually like we would have organized the actual project itself into various components, and then like every week we would have tried to like work on those particular components. And we would have also managed our time more efficiently going again with like trying to set up mini goals for ourselves. And also we would have tried to find simpler solutions for our project because overall I feel like our project was a bit too complicated in terms of like what we had to achieve. And we would have also like researched some of the parts beforehand because I felt as if we like would have researched like a lot of parts beforehand, we could have like saved our time because some of the parts weren't working. So we would have actually tried to like research more of the components of it.
So, summary and conclusion. So basically, designing the project, the final output, it's been very nice. Facial recognition, implemented with the grammar system, has very high possibilities for implementation in the future, possibly in retail stores. With this implementation, we hope to differentiate between shoppers and shoplifters more easily, as well as make sure the loss record is not lost anymore. Yeah. We would like to thank Ms. Gary Center for helping us with this project and aiding us in the design of this project. We would like to thank Mr. Shulman. Mr. Shulman is basically a psychotherapist who specializes in different personalities of shoplifters and understanding how shoplifters do the act, which really helps us in creating a grammar system and detecting those different personalities of shoplifters. We'd like to thank the Monroe Township Police Department for the interview that we